Welcome back. Today we will talk about test automation on a unit level and frameworks that support that. In particular, we will discuss about jUnit framework. jUnit is a simple framework to write repeatable tests. It's an instance of the XUnit architecture for unit testing frameworks. It's an open source utility and you can download it from www.junit.org. In this lecture, we will talk about some more advanced features of jUnit, like assertions, annotations, testing of exceptions or timeout for tests, and etc. So let's start. A hello world example for a test case in jUnit framework would look something like this. We would write an annotation to declare that this method is actually a test. We will put the name of the method and then the actual method within the test automation framework. We have the default one, which is fail, so we want to force this test case to fail, or we want to invoke a method called assert equals, which compares two parameters, the first one being expected value and the second one being actual value. In this example, both are predefined strings, while in reality the second parameter of the assert equals method would be a returned result from some other function of your software. There are different assertions that you can use in jUnit framework. We used in previous example assert equals, which essentially asserts that two objects are equal. But we can also compare arrays. So we have assert array equals, which says that asserts that two arrays are equal. We can also assert true or assert false, where we are essentially comparing that this condition is true or false. We can also assert null, which essentially compares that an object is null, or assert not null, which compares that an object is not null. Except for assert equals, we also have assert same. With the difference is that with assert same, we are comparing that two objects refer to the same objects, while assert equals compare that two objects are actually equal. And of course, at last, we have assert not same, where we are comparing that two objects do not refer to actually the same object. We showed that the first hello world example one annotation, which was the first one, test, declaring that a specific method is actually a test case. Additional annotations are before and after, stating that a method that has annotation before will be executed whenever a test case is before any other test case is executed, and after will be executed immediately after each and every test case is executed. Before class and after class methods are executed essentially only once for that specific class. So one example could be that we want, for example, to connect to a database, and we will put this method as a before class method, or we want to disconnect from the database once we finished executing all the tests. So this will have annotation after class. Several classes of tests could be put in one test suite. This is usually done manually, and you will use following annotations: run with, and then you will provide the suite classes, the method that are containing with that suite that you want to execute. Often it's not recommended that you write test cases such that they are dependent on previous tests, so you should really avoid doing that. But if there is a need to enforce order of test execution, you can do that by importing the two functionalities from jUnit called fix method order and method sorter, and then you have to use annotation named fix method order, where you want essentially tests to be executed by their name. But once again, this is generally not recommended to have any dependency in your tests, so really try to avoid that, or think about your structure of your tests differently. Testing exceptions is an interesting problem in general, where you want your code to throw an exception, and you want to test that the specific exception was thrown, and the test will pass if that's the case. So in jUnit there are actually three possibilities how we can do that. One way is that we provide as part of our test annotation for the test method in jUnit, we can add this parameter expected, and then the actual class of the exceptions that is thrown by the method that we are testing. Another way how you can test exception is to use try-catch combination. So we can try to execute a method under test, and if we actually succeed doing that, then our test fail, because we are expecting this method to throw an exception. And if we catch such an exception, then we actually made this test pass. So that's one more way how exception could be tested. And then there is a third way of doing that, and this is I think specific to jUnit 4 version 4, where you can use expected exception rule. So this is another annotation in jUnit. So you can at the very beginning of your testing class specify a rule where it is expected that tests are throwing specific exceptions. Another addition to the jUnit is that you can use assert that method instead of assert equals or assert same and similar. What would that look like? So for example, you can, if you want to test that its assertion is true, usually you would do it something like this. So you would say assert true 15 greater than 20, but you can also use this assert that method, where you would write it like assert that 15 is greater than 20. As you can see, this is much more human readable, although it's still written in the form that could be executed by the jUnit testing framework. But actually that's not the main benefit. The main benefit is actually in the output results of executing such a test case. So for example, assert that 15 is greater than 20. As a result, we'll say expected is a value greater than 20, but 15 was less than 20. And this is a very, very descriptive kind of output results from a test case. In our original example, where we would just call assert true 15 greater than 20, as a output result we will just get assertion error without any actual details of what is the cause of that error. Sometimes we need to ignore a specific test. Maybe there is a functionality which is still not implemented, or maybe we are modifying some functionalities and this is not completed yet, so we don't want tests to be run on that one and fail. So the simple way could be to just remove the test annotation, and then the method will not be considered as a test case from a jUnit test automation framework. But more appropriate way is to use the ignore annotation. So if we can, before the test, if we put the ignore annotation, and then we can even specify a comment, then such a test case will not be executed, but it will be listed in the list of test cases, and this comment that it's ignored will be written down. So it's much more appropriate to use the ignore annotation. Also, you can create a test case such that you want it to finish within a certain given time frame. So for example, tests that run for too long, you can automatically declare them as failed. And there are two ways how you can achieve this. We have a timeout parameter within the test annotation, So essentially we just write the test as we do it normally, but then we provide this parameter timed out, and we specified the number in milliseconds of how long we want to wait for this test to finish. So 1000 milliseconds would be equal to 1 second. Another way to do this is to specify a rule, but that applies actually for every test in that class, which could be actually useful in some cases, but sometimes not. So it's really case specific. Parameterized test. This is a replacement for writing several tests where the only difference is actually in the input and expected values. If you want to avoid writing 4 test cases where the only difference between them is the actual input values provided for the method under test, then you can create one parameterized test, which will then, once it runs with the jUnit framework, it will be instantiated as several test cases. So when you actually run this test, it will be as an output, it will be reported as 4 test cases which are run with 4 different inputs on a method under test. Assumptions is also a very nice feature of jUnit. There is a possibility to it expresses a possibility to run tests conditionally. For example, you would like to run a test, but only if you are able to connect to a database. If such a connection doesn't exist, then the actual test should not be executed. And this is very good if you are using the same tests in different environments. So, for example, if tests are used on a developer's machine and later on the integration server, continuous integration server, the same resources may not be available for the developer as on the integration server. So this is again a very nice feature of jUnit that could be utilized for test automation. With that, we actually conclude this video on jUnit, and now it's time to do some practical work.